Good afternoon, everyone. Before starting our presentation, I would like to point out that English is not our primary language. Therefore, if any of us mispronounce any word, just know that we are trying our best. Stating this, I will now proceed to our presentation. My name is Jan Figueroa. I have the privilege and honor to be chosen as this year's team leader, representing the University of Puerto Rico. Our team is composed by Yocho Casiano, Gilbert Ramos, Norberto Martinez, Mark Rivera, and Hector Ramos. And finally, from the list, our advisor, Dr. Evi de la Rosa. In order to obtain and achieve our topography map, we divided our process into 3 simple phases. Phase 1, fieldwork, explaining our planning before entering the work area and the methodology applied. Phase 2, the office method, explaining the process behind the result and the data obtained. And finally, phase 3, data analysis and mapping. Now I will leave you with Jocha, who will explain our planning before entering the fieldwork.
To know the error of each instrument, we realized a collimation test the day before the competition. We set a horizontal distance equal to 60 feet between 2 pads. The instrument is placed in the center. Then we reduce the distance of foresight to 10 feet and increase the distance of backside to 15 feet. The collimation result for both levers are 0 feet for one and negative 0.02 feet for the other one. The team structure to optimize fieldwork procedure. We divide the team in 2 groups. One of them was in charge of laying out the grid, and the other group was in charge of conducting the survey. The survey area was located south from West Serene Avenue and west from South Wallape Way. We started the survey with 1 point with no coordinate and elevation. The image shows was achieved by conversion of NAT 83 coordinate to UTM 11 zone south. To help us fasten the process, carb zone was used to make the conversion.
The fieldwork the produced main was find the true north and identify the magnetic declination. Orientation with data provided. Defining the load dimension. Establish the 4 corners of load. Construction the grid and closed loop circuit or level. The equipment used in the field was wide hairbreadth level, that this one was donated. Fiberglass Philadelphia rod, a steel tape of 66 feet, stake, plugins, compass sunto, and plumb bomb.
As soon as we get to the site, the first thing we did was find our orientation. To find the true north, we used the Sunto compass to identify the magnetic north. With the magnetic north, we have the correction to the magnetic declination that was 11 degrees, 42 minutes to the east. The true north oriented our grid 20 degrees east. To define the corners of our grid, we make a cross in distances of 20 feet using the 60 feet steel tape in each direction, north, east, south, and west, until we reach a horizontal distance of 104.35 feet in each direction, starting at the temporary survey benchmark. We project the lines to the boundary of the grid, and in the point that the line intersect, we mark the corner of our site. We validate our orientation in different spots on the site using the compass. To construct our grid, we use 3-4-5 triangles method. Before take any measurement, we verify that the grid was correctly oriented. We don't use the vernier or level azimuth ring to orientation, just the compass. Thirdly, we decide to construct a grid with 5 by 5 feet square, but because the density of point we decide to change 10 by 10 feet dimension. We maintain our 90-degree angle using 2 steel tapes. Our working site covers an area of about 208.71 feet by 208.71 feet and collecting more than 500 points. The site, like you see in the picture, we have a gap. The gap we have in our grid is because in that area the terrain maintains a uniform surface. We want to make sure not ignore any detail, but because of time, we have to jump that corners. We have a closed circuit with only one turning point to maintain a high precision. Less setup we do, most accurate the circuit will be. 3-wire leveling was used in the closed loop to maintain a good precision. We have one turning point because we set up in a strategic point in which we have a good visibility across the site.
Some of the difficult and obstacles we encountered in the field were scrub that affect our work because some points were near or on top was hard to place the rod and steel tape can be crossed. A strong wind, they make that the electric was slowed down because the wind affects to keep the road stable and also was dusty. Last, not flaggings. The high density of point we surfaced and short gate of flagging. At the same time, some guys we have created grid, other was collecting the flagging of the point already taken. Possible error, reading on the rod and keeping the rod stable.
Okay, to determine the horizontal precision, the horizontal distances were measured using steel tape, both clockwise and counterclockwise, and by stadia. The perimeter of the closed circuit added to be 250 feet, obtaining a horizontal precision of 1/4, about 4,300. Okay. Once all field data was collected, the computation phase commenced. Because of the irregular arrangement of the grid, which contained more than 500 points, it was designed then in AutoCAD. Once the grid was created in AutoCAD, it was then rotated to match the bearing of the west adjoining line, and georeference with the given coordinates of the temporary surveying mark. The file then was imported to Civil 3D to create a point group, exactly. This helped us create then a cone delimited file to then add the elevation to each point. 2 programs were created. The first program was in charge in calculating the elevation of each of the points, calculating the sum of the back sides and fore sides, and the difference between the initial elevation and final elevation to help us determine the error. The second spreadsheet was in charge in calculating then the perimeter, which was made by Stadia. Once the elevation has been established and assigned to each of the points, it was then exported once again to Civil 3D to create a surface. Now Hector will be explaining the process, the analysis behind the process.
For data analysis, we got a great amount of data and measurements. The closed lab, we can see that there is no need to adjust any elevations of the boundary because of the short distances we use. The grid proved to be effective in order to establish contour lines with a dimension of a 10 by 10 grid. And as we observed how the contour line behaved according to the data retrieved on the field. In the 3D model, we can observe how the surface has a very clear perspective and representation of the site we were working on. We put up a couple of pictures of our 3D model from different angles. You can see we have the 3D model observed from a northwest corner. In this one, we can observe a southeast view. This other, we can observe a southwest perspective. And in this slide, we observe the northeast corner. To validate our work, I will leave you with Jan to discuss about work.
To validate our topo and work, we created a secondary circuit using the second level that we brought from Puerto Rico. Using the second circuit and comparing it with the original one, we obtained measurements in which at least few selected elevations does not exceed half of the counter interval. After processing our data and validating our topography, we ended up creating a map, as you can see there, of 1 acre lot with a CI of 1 feet. It was not an easy task, but believe me, it was really challenging for us. The final thought about this work. First, this was the first time working in a desert environment, different from the tropical weather we are used to. First time using US customary system, which only use 2 decimal points. We work with the metric system, round to the 3rd decimal. In the slide, 1 millimeter is equal to 0.0033 feet. Not to confuse you guys, this next bullet is our vertical precision, and as stated in the slide, in order to achieve meet standard required 1000, we deliberately introduce a minimal possible error of 0.01 feet, obtaining a precision in 1 or 25,000. But as I said before, this is not the horizontal precision, it's only the vertical precision. We never ignore any data that can alter our work. That's why we decided the 10 by 10 grid dimension, trying to cover the most area possible in the site. To finish our presentation, we created this short video. This video will show you our journey and distance traveled just to get here to Las Vegas. As you can see, we left Puerto Rico. We are flying right now. It took us like more than 8 hours to come here. Just flying, and there we go, right there, the Luxor Hotel. To finish with an estimated 3,000 3,165 miles just to get here to Nevada. Last but not least, we all wanted to thank the NSPS for providing us the opportunity to participate in this year's competition. Even though we were hit by 2 massive hurricanes this past year, we are blessed to be here and blessed to have this opportunity to represent our country, Puerto Rico. Now we're open for questions.
Questions? From the audience, question right there.
You said you guys are used to using the metric system. I'm wondering what kind of steel tapes did you bring? Did you bring it in meters, or did you bring it in one feet, or did you have to get one here?
No, we bring a steel table. You have feet and the other side meters.
Yeah, they asked me, I made them bring the ones in feet. Got a lot of emails from them about some of the differences in tools. So
It was hard to find fiberglass rod we fit.
you guys figured it out, but yeah, there was a lot of back and forth because they said they use the metric a lot. And it's like, nah, I think we need to all be working in feet here. So, but they did a good job getting the stuff somewhere. So, any other questions?
I got a question. How did you got a lot of points. How did you go about collecting that many points?
Okay, well, we had that many, that great density because we are used to work with a pretty rough and pretty dynamic topography over in Puerto Rico. So when we come to here in the desert, which doesn't have that much elevation, but still there are some differences. We decided we wanted to make a denser grid so we can show better the wave contours, exactly, wave contours and the area.
I guess maybe I didn't really say it correctly. Like, how did you break up your team to collect that?
Oh, okay. Well, we were divided into 2 groups actually. We were 3 of us were working on the taking out the surveying, and while the other 3 were doing.
We were running right by side, taking the flag. Every time we took a measurement in one of the column, they will take, after the wave finished with the column, we will rapidly take the flagging and start with the flagging on the other side of the column.
Exactly.
So we were running on all day long.
Yeah, both of the procedures were taken at the same time. And yet again, we are used to work with this many times.
Pretty impressive.
Kind of human laser scanning.
Yeah, always.
Any other questions? Okay, thank you very much.